Okay, good morning, dear students. In the last lecture, we have completed our last unit, unit number 6. So today, we will take a revision of all units, maybe this lecture and maybe a next lecture, so that what we have learned throughout this semester in this subject that we have to just look at. So subject is power electronics and applications. So power electronics and applications, name of subject. So to understand the construction, switching characteristics and protection of a power device, this is our first course objective. And to understand the protection circuit and triggering circuit for power devices, that is the second objective. And then to give an exposure to the students of working analysis of control rectifier, inverter, chopper, AC voltage control for different load. Okay, so already we complete the syllabus. So what we get from the syllabus, that is outcome of this course. So everyone maybe very well understand the basic principle of a power conversion, that is AC to DC, DC to AC, DC to DC, right, and AC to AC. So these are the different power conversions. Then everyone is understand the requirements or need of a triggering circuit or a gate drive circuit for power devices, because power device without triggering circuit or a gate circuit, you cannot turn on your power device. Okay, you are not turn on or not turn off your power device. So proper triggering circuit or a gate circuit is required. Okay, so that everyone is able to understand, everyone is able to explain the different type of triggering circuit, gate circuits, and etc. Then design implement protection circuits for power devices. So it is already covered. Understand, design, analyze different power electronic converters, and then utilize power converters in different industrial applications, right? So already we have seen 2, 3, 4 application like induction heating or induction cooker, then battery charger, then UPS online, offline, right? Then electronic ballards, etc. These are the applications of these power converters in some different industrial applications. So it is already covered. So a whole syllabus is covered. It means that these all 4, 5 outcomes fulfilled, right? So I'll just overview the syllabus, what we have seen in a unit number 1. So unit number 1 is nothing but the basic constructions of a component, right? So before that, we have seen power electronics versus electronics, scope and application, interdisciplinary nature of power electronics, and classification of power converters. Okay. Then power MOSFET, that total 4 devices are given in your syllabus. First one is the power MOSFET, IGBT, SCR, and triac. So we have seen all 4 devices: power MOSFET, IGBT, SCR, and triac. In power MOSFET, we have seen construction of a power MOSFET. Before that, I have explained you the MOSFET only, that is a low power MOSFET, the construction of low power MOSFET, how it works, and so on. Even I explained you the JFET, the construction of JFET, difference between JFET and MOSFET, even difference between MOSFET and BJT, right? So that already we have covered. Then we have seen the construction difference in a low power and high power MOSFETs. So in high power MOSFET, or you can simply call power MOSFET, Additional drift layer is added so that the voltage handling capacity of powered MOSFET increases, and the nature of that device is a vertical so that the current handling capacity also increases. So this is the difference between low power and high power MOSFET construction difference. Then we have seen operation of a MOSFET, then static characteristics, that is operation of MOSFET with the help of static characteristics. Then the most important switching characteristics we have seen. After that, safe operating area, and then applications of MOSFET. Okay. Then second device we have seen IGBT. It is a combination of BJT and a MOSFET, right? So advantage, that is high gain as like a BJT, low on state drop as like BJT, and high input impedance as like a MOSFET. So the advantage of MOSFET is high input impedance and no thermal runaway in a MOSFET. So these are the two disadvantages of MOSFET, and two advantages of a BJT. One, very low on-state voltage drop and high gain that is achieved in IGBT. So we have seen the construction of IGBT. There are two types, punch through and non-punch through, that we have seen. Then operation, again, steady state characteristics, switching characteristics, and safe operating area, right? Then we have seen the gate drive circuits for BGT, sorry, IGBT, and for MOSFET. Then the next power device, SCR, which is always used in a power circuit if power is greater than 5 kVA. So construction of SCR, silicon controlled rectifier. Uh, its name itself uh, give the information about the application of SCR, that is, it is used as a rectifier, control rectifier basically. Silicon material is used, not germanium. Germanium is a heat producing element and not used for high power application. So only silicon is used for the construction of SCR. So silicon controlled rectifier, it is a controlled rectifier. Diode, if you are using simple diodes, then that is called uncontrolled rectifier. But this is a controlled rectifier, as already we know that how the output power is controlled, right? The construction of SCR, the working of SCR with the help of transistor analogy as well as VI characteristics, right? Then different ratings, and then we have seen triac as a fourth element. So construction of triac nothing but a two anti-parallel SCR, the operation and characteristics of triac. So this first unit, nothing but the introduction of power devices, right? Then in the second unit, we have seen the gate drives and protection circuit. So whatever devices we learned in the first unit, for these devices, the gate drives or base drives are required. Otherwise, these devices never conduct. So gate drives and base drives we learned in a unit number 2. At the same time, these are power devices. They are operating at high power. So definitely the heat will be produced. That heat will be dissipated in a proper way. So we require a protection circuit to protect our power device from any high temperature as well as any high voltage and high current rating, right? So that we have seen here. Gate drive circuit for SCR triac need requirement isolation of gate and base drives. So we have seen a pulse transformer and optocoupler. Then UGT we have seen a triggering circuit. Then diac using triac triggering using diac. Then power MOSFET and IGBT microprocessor based circuit for electronic applications, right? And then we have seen protection circuits for power devices. So first one, cooling and heat sink, that is to protect power devices from any high temperature. Then snubber circuit, then voltage protection by selenium diode, MOVs, then current protections, that is by using fuse and Grauber circuit, right? So in this unit, unit number second, we have seen different triggering techniques and see, my dear student, whatever number of techniques we have seen is not the all techniques. There are maybe a more number of techniques available, but as per your syllabus, how many number of techniques are given that we have covered, right? And at the same time, whatever the protection circuits are given in your syllabus that we have covered, but protection circuit is not limited up to this. So uh, whatever not given in your syllabus that we have not seen, but all the topics we have covered, whatever given in your syllabus. Okay. So till this unit second, we have seen the protection circuits from maybe high voltage or a change in high voltage, then change in high current, high rate of change of voltage, high rate of change of current, then temperature we use heat sink. If heat sink is not sufficient, then we are using some cooling techniques so that the temperature will be dissipated in a proper way. Okay. So till second unit, we have seen triggering circuits and protection circuits. Now, in unit number three onwards, we have seen the application of these power devices, right? Application of these power devices, what we have seen in the first unit. Okay. So first application is AC to DC converter, in which we have seen single phase, semi, full converter for R load, for RL load. Then concept we have seen line and force computation means what? Effect of freewheeling diode, performance parameters, then three-phase semi and full converter for R load, RL load, design of control circuit for single phase and three-phase control rectifier and applications of control rectifiers. Then we have seen DC to AC converter, also called as a inverter. DC to AC converter is also called as inverter. So at the start of this unit, I have mentioned the basic aim, main aim of this unit, because the inverter is not only used at your home for emergency purposes, but the main aim of inverter is to convert single phase or a three phase line frequency to the variable frequency. The frequency variable or variable frequency is the main aim of inverter. Not only frequency, you can even change the voltage also, right? But the main aim of inverter in industry is to change the frequency. So line frequency is a 50 hertz, which is a fixed. So if we require a variable frequency, variable voltage for to drive to control AC drives, in that application we require a variable frequency as well as variable voltage. So in that situation, we convert AC into DC first using above converter, that is unit number three. And then we use inverter so that again DC into AC with the output frequency, that is variable frequency, variable voltage can be achieved, right? So single phase and three phase inverters we have seen. Then variable frequency control, sorry, need of PWM inverter, voltage control of inverter, and so on. Even we have seen AC voltage controller, right? Afterwards, we have seen DC to DC converter. Again, simple example of DC to DC converter is electric vehicle in which we are using battery as a source, right? But the battery voltage is a constant, so motor speed must may be constant, but we require a variable speed of a DC motor. Otherwise, the speed of your electric vehicle may be constant, right? So to increase or decrease the speed of DC motor, we require a variable DC voltage. And that DC voltage is available, that is variable DC available from DC to DC converter called as a choker. right? So working of a step down chopper, then step up chopper, their performance parameters, then a buck and boost converter. Buck converter, it means a step down converter, boost converter, a step up converter, two quadrant chopper, four quadrant choppers, applications of chopper, SMPS, and so on. So this is already covered. Then in last unit, applications of, okay, so again internet issue, so that we disconnect from the meeting. Uh, so this is last unit what we have already covered in the last lecture, power electronics applications. In this unit, the applications of about three unit that is given here, that is DC DC converter, DC to AC converter, and AC DC converter. So applications of about three unit is covered in unit number 6. This is not application of power devices, it is application of circuits which we learn in unit number 3, 4, and 5. Okay, so first application is HVDC transmission system. So HVDC transmission system we have seen, in which conversion of AC into DC is done by using AC DC converter. After that, using some filter and then using DC link, the energy transferred from one place to another place. At the receiver side, again, there will be a converter called as inverter, which converts DC into AC, desired frequency, desired voltage level, right? So there is no need of synchronization between transmitting and receiving station by using HVD transmission. So we have seen various methods of HVDC transmission system. Then second, we have seen UPS, online, offline UPS. Then battery charger we have seen. Then we have seen induction heating, then electronic lamp ballast, right? So these are the applications what we have seen in a last unit. I have sent you the chapter wise book chapter actually of MD Singh and Khan Chandani. Even I'll send you the chapter number 6 or unit number 6, so that total notes what we have taken from the book that is present in uh, that unit. Okay, book. So I'll just show you the book. This is actually a chapter number 16 of MDC and Khan Chandani. So this chapter, this is a complete chapter, chapter number 6, as per your syllabus, power electronics applications, right? So start with the UPS in the book. As per your syllabus, HVDC is the first part. That is also present in this unit. But the types of UPS, whatever types of UPS available in your syllabus, that already we have covered. Some additional types are given here. So next one is uh, switch mode power supply, SMPS, then HVDC transmission system. Just a minute. Okay. So HVDC transmission, bridge converter, and so on. Okay. So this is a HVDC transmission. So in which we have seen overall layout. Then we have seen types: monopolar, bipolar, homopolar, and back-to-back tie connection. This is a diagram for monopolar. The working is given, explanation about monopolar is given. Bipolar, the working or explanation is given here. Then homopolar, whose explanation is given. Then back-to-back tie connection, whose explanation is given. Then advantage, disadvantages. Advantages are approximately 15, 70, 20, 17 advantages are given here, disadvantages, right? Then this is not a part of your syllabus, it is VR compensator, not a part of your syllabus. So don't see the maybe other topics which are given, but it's not a part of your syllabus. So induction heating is a part of your syllabus. Then even direct heating is also given here, but it's not a part of your syllabus, so I'm not taking that. Advantages of induction heating, disadvantages, induction cooker is application of induction heating. Uh, then direct heating is also given in a book, but it's not a part of your syllabus. Then applications of direct heating, comparison is given. See here, comparison of induction heating and direct heating, that is given. You can simply read the comparison. That is sufficient to understand what is the difference between induction heating and direct heating. Okay, so you can see here, switch mode welding is not a part of your syllabus. Electronic lamp ballast is a part of syllabus. So that is given. Battery charger is a syllabus part. Then emergency light system is not a part of your syllabus. Okay, static DC breaker, etc. Now the remaining part is not given in your syllabus, so don't see whatever the remaining syllabus is given, right? So I'll just I'll just cover the last unit what we have seen in detail, so that in next lecture I'll cover unit number 5 and 4, so that the most of the syllabus is revised, right? Because most of the students may be present or absent. I don't know exactly at the time of lecture. So I just take a revision of last unit, and then in the next lecture, I'll take a revision of unit number 4 and 5. Okay. So see, uh, high voltage DC transmission. That is the first part of unit number 6. So overall layout, if you see here, AC supply voltage, okay, then filter, this filter will remove any kind of EMI which is added in your supply voltage, right? So any kind of electromagnetic interference or maybe high frequency components if added with your line frequency, that will be removed here. Then transformer, that is a step up or step down transformer, so transformer is given here. Then output of transformer given to the converter, this is a AC to DC converter, AC to DC converter, okay, AC to DC converter, because supply is AC and which is converted into the DC with the help of this converter. Now this converter is definitely a uh, three-phase converter, right? The supply voltage may be a three-phase because single phase having low power. So normally for low power transmission, this HVDC system is not used because uh, the overall cost of HVDC transmission is high, and if you are transmitting low power, then there is no use of this HVDC transmission, because overall cost of this system is so high, and if you are using it for low power, then definitely it's a wastage of this total system, right? So normally the supply is a three-phase AC. So converter is also a three-phase converter which converts AC into DC, right? After that there will be again a filter, okay, L filter and then C filter, combination of these two filters, so that the maximum AC components are removed and pure DC plus kVA minus kVA. This is basically a bipolar. So this is a DC link transmission, single wire or sometimes double wire, right? So this is transmitting wire maybe for longer distance, 1,000 kilometer or more than of that you can use in a DC transmission system. Then at the receiver side, this is actually a transmission part, this part. Now the remaining is a reception part, right? At reception side, at the receiving station, there will be again a filter which remove any kind of AC components if added, right? Normally very low AC components are added, but still filter is used to remove that components. After that, again there will be a converter. This is a inverter. DC to AC converter, DC to AC converter. right? DC to AC. Again, it's a nothing but a three-phase inverter. So conversion of that high voltage DC into AC, and then again there will be a transformer according to the requirement. Sometimes it may be a step down transformer. So after that again there will be a filter, and then this supply is distributed among the industry or home, right? This is the overall layout of DC transmission system. So it has a four types: monopolar, bipolar, homopolar, and back-to-back tie connection. Monopolar HVDC transmission system. This system has one pole and earth. You can see here only one pole, or you can say only one wire. Okay, only one wire is used, called as a monopolar, single wire. Disadvantage: if this wire breaks somewhere, then definitely the transmission is stopped. That is a major disadvantage of monopolar, right? But major advantage is a single wire is required. Okay, now as we know that the DC is plus and minus, or you can say plus and ground. So ground is given to the earth. Definitely the distance of station with the ground element is few tens of kilometer, right? Simply to avoid the galvanic effect, these earth ground is a place maybe something few tens of kilometer away from the transmitting and as well as receiving station. Okay, so at the transmission there are two wires. One is pole, another is a ground. But after some distance, few tens of kilometer, this ground is directly inserted into the earth. Okay, so earth itself acts as a conductor for return path, right? This is a transmitting path and this is a return path. So return path, earth itself acts as a return path. So this is called monopolar, sorry. Only one pole is there. Bipolar, in which there are two poles, plus minus we can say here. One is plus pole, another is a minus pole. Again same thing, the earth or return path is given through the earth, right? So this is a positive pole, negative pole. This is advantageous because if one of the pole is break, then the second pole is continuously working, right? So in AC network, then converters, again inverters, and then AC network. So this is called bipolar. Then homopolar, in which the again two poles are used but having same voltage, maybe either positive or maybe either negative. So pole 1 and pole 2 both are connected to the same line, but this is again advantageous because if any one wire fails, second will be working. So the disadvantage of monopolar that is overcome in a homopolar. So two wire system is used. Return path is again a ground or earth, but two poles, so that if one pole fail, then another pole will be continuously transmitting the DC voltage, and then back to back connection, tie connection, right? The system has a no DC link between converter station, a rectifier and inversion mode are at the same location. So converter as well as inverter is at the same location. AC converted to the DC and DC onto the AC and then given. But definitely at this AC may be a different kind of AC, different frequency, different voltage, and so on. So only for that purpose, this type of connection or this type of circuit is used, right? So advantages are given. I'll just forward this PPT so that you all must be read thoroughly, and this is helpful for you for your preparation, right? Now, next one is a uninterruptible power supply. We have seen uninterruptible power supply, that is a UPS. So UPS, the main features of UPS provide good quality power to the load at all conditions, regulate the load voltage when mains voltage fluctuates, provide complete isolation between the load and mains, suppress the line transients, and so on. So advantages of SMP, sorry, uh, UPS, you can say. or major features of UPS. Then single phase or three phase AC mains, then rectifier plus charger, then inverter, then filter, then critical load. This is a block diagram of a generalized UPS. Okay, but we are having two types or three types of UPS. That is online UPS, then offline UPS, and line interactive UPS. Okay, so first one is the online UPS. Online UPS, it means that also called as inverter preferred UPS. So output is always preferred through inverter, not directly, right? Output is always preferred through inverter. That is called online UPS. Second one is offline, line preferred. So output or load is always feed through line. Whenever line fails, only that time UPS works. The first one, online UPS, the output is or load is always feed through inverter. The line voltage is not directly given to the load. So advantage is the fluctuation in a line is avoided, right? So whatever the advantages that is given here, good quality power to the load, regulate the load voltage, provide complete isolation between load and mains, and so on. These are the advantages of online UPS, right? And then line interactive UPS. So first one, online UPS, in which the main switches are continuously off and UPS switches are continuously on. So supply is given to the a converter, that is a AC DC converter. This DC is given to the inverter, as well as it will also provided to the battery for battery charger, right? Then these DC again connected to the AC, and through these switches it is fed to the load. If suppose if suppose the battery or this particular inverter fails, right? Then these switches automatically turns off and these switches are turns on. The turn on time is up to only 5 milliseconds or less than of 5 milliseconds. So this switching from UPS switch to main switch is very fast, right? So this will be work as a online UPS. Then offline UPS, in which the main switches, static switches are continuously on and UPS switches are continuously off. If suppose mains fail, only that time these switches turns on and battery to inverter through this switch, the load is fed, right? So this is called normally off, or you can say offline UPS. So such type of UPS are used at your home as an inverter. Then line interactive, that is again same. Line is on, then directly feed to the critical load. If line fails, then battery back is given to the critical load. No inverter is connected between the AC mains and load. So it is called as a line interactive. Okay. So these are the types of UPS we have seen. Then battery charger we have seen. Whenever the switch is S1 is on, then S1 is on. This is a rectifier. So the voltage at the P is increases. That is a positive voltage. So automatically voltage at O also increases. And whenever the voltage at O is greater than the on voltage of a diode, this diode D3 turns on. If diode D3 turns on, current flows through the gate, but still SCR is remains off as soon as the voltage at O is greater than the triggering voltage of SCR. SCR turns on. Actually, the gate voltage required must be greater than this battery voltage, right? If it is equal to 12, if it is equal to 12, then SCR remains off. So your battery charger automatically shut down. So that we have seen. Then we have seen electronic ballast. So the first one is the electrical ballast, which is normally used in old tubes, fluorescent lamps. But nowadays, the electrical ballast is replaced with the electronic ballast. That is the circuit given here. AC 50 Hertz power factor correction, then uncontrolled AC to DC rectifier, then high frequency inverter, and then high frequency AC is applied to the lamp so that the efficiency of a lamp increases, even intensity of a lamp increases, right? So this is electronic lamp ballast. Then we have seen induction heating. So a very simple concept, high frequency or even simple 50 hertz voltage if you apply to the coil, and if you apply voltage to the coil, then a magnetic field is produced in a coil, which will transferred mutually into the metal piece, that is a metal object, right? So that EMF is induced in a metal object. Once EMF is induced, then magnetic field start to produce across the metal object, so that eddy current start to flow through the metal object. And once the eddy current start to flow through this particular object, then definitely the object will be heated, and that object heated, it means your induction heating. So the concept is given here. Okay, then this is the end of unit number 6. What we have seen, uh, the applications of converter, inverter, chopper, etc. That is given in a unit number 6. So last 1 minute is remaining. Everyone give your attendance fast in the chat box. Give your attendance in a chat box. I'll share you the PPTs as well as the book chapter immediately after this lecture. Last 1 minute remaining. Give your attendance fast. Only 46 students are giving attendance. Actual present students are more than 55. Everyone give your attendance. Give your attendance fast.